Hello class, we're getting ready to start our lesson on 5.3 today. Remember today's our block day, so we're going to not only do one lesson, we're doing two lessons today. And our first task is to use proportions to find parts of a whole, an actual whole amount, or a percent. So it could be one of those three things that we're finding today. And we're going to be using proportions to solve. Now we're recording today because we are missing two precious souls. Let's say hello.
Hey, Mia. Hey, my feet miss you.
Zach says his feet miss you. Oh boy. Okay, but we want to say hello to Miss Mia and Miss Caitlin, and we hope you guys, wherever you are, that you are feeling better if you're sick. So anyway, let's go ahead and get started with example 1, and we're going to use a proportion to find this particular problem. We're trying to find 45% of 32. Okay? Now I learned this really cool trick several years ago, and this is the proportion that we use. We do is over of equals percent over 100. And that is the best percent, the best proportion that I have told kids if you're solving a percent problem. This is a great way to set it up. It's easy to remember. You just plug in those numbers wherever they fit. Okay? Yes, sir? Absolutely. Go right ahead.
45 over 100 equals 32 over x.
Almost. You almost have it. You almost have it. So good job. You're seeing it, which is great. Okay? Let me give you some background, and I'm going to come back to you and see if I can change your mind on positioning of some of the numbers, okay? Your is number, if the word is happens to be in the problem, it's not in this one. All it says is find 45% of 32. You don't see the word is, okay? But normally, the number closest to the word is, it can come in front of the word is, it can come after the word is. That's what makes this number pretty flexible. That's where you position that number, is right there in the is position of our proportion. So you'd put it right here, okay? So I don't see an is number because I don't see the word is at the moment, okay? Now the word of is more restrictive. It is more restrictive than the word is. You know you have an of number. You see the word of and then the number. That's your of number. Do you see the word of and then a number? You sure do. Okay? That is going to be your of number. And that you will positionally put that where the word of lies in that particular proportion. Okay? Percent's really easy. If you see a number with a percent sign behind it, that's your percent, and that's where it goes always over 100. Okay, there's no mystery here. Percent always goes over 100. The is number, the number, remember, can come in front of the word is, after the word is, somewhere around the word is. That's your is number. And your of number, very, very restrictive, can only come after the word of. Okay, so let's fill this out. Okay, I'm going to rewrite it over here a little bit smaller. Is over of equals percent over 100. Let's say that together. 1, 2, 3. Is over of equals percent over 100. Okay? Get that memorized. That's a great proportion to memorize. Okay? Is. Do we know an is number? Do we even see the word is? No, we don't see the word is. So let's call that S. Okay? Do you see the word of? Yeah. Is there a number right after it? That's your of number. Good job. Do you see a percent?
45.
45. And you always put it over 100. Okay? There's your proportion. All right, how do you solve a proportion? All right, so let's start here. What's x times 100? 100x. Good job. And then I need a little bit of help. That's why the calculators are important. Hang on. 45 times 32. Let me get one person. Chase, go ahead and tell me. 1440. Okay, good job. Now, how do you solve this one-step equation? Divide each side by 100. So take your answer, 1440, divide it by 100, and Jaden, what'd you get?
Hold on. Dang it. 14.4.
14.4. That's our missing number right here, okay? What we just found was part of a whole, okay? The whole amount, the of number is your whole amount, 32. Out of that 32, how much of that is equivalent to being 45%? And so we're saying we think that number is 14.4. Is it possible that it could be a decimal answer?
Yes.
Clearly, yes. Could it be a whole number answer? It also could be a whole number answer. Be ready for either event, okay? All right, I'm going to stop the recording right here, and I want you guys to try. Okay. All right, we're back, and we're getting ready to set this problem. I'll try to give you some hints based on our conversation before. So Chandler, let me get you, how did you set this proportion up? Where did these two numbers go?
X over 95 equals 74.
You got it. Excellent job. Excellent job. Okay. So Miss Hannah Rock, how do we solve a proportion? So let's cross multiply. So x times 100, that'll be our 100x. And what did you get when you multiplied 74 times 95?
I got 7,000. Wait, I got 7,040.
7,040. Did you guys get that? Okay. Did you have a calculator? No. Okay, that's why. What did you get, Chase? 7,030. So you're pretty close. All right. So 7,030. Okay. And Miss Caroline, when you divided each side by 100, what is our missing number?
70.3.
70.3. Good job. Okay. So that's finding part of a whole. When you're given the of number is your whole. The of number is your whole. So really, is over of really means part over whole. That's all it means. Is your part, of is your whole. And then, of course, percent is the percent. All right, let's flip to the next page. All right, so let's take a look at example 2 and see what this looks like more of a word problem, which can be intimidating, but let's see if we can dissect it a little bit, okay? This month's heating bill is 130% of last month's bill. Last month's bill was $46. Find 130% of 46. So here they set it up for you right there. There's the setup. We're looking for 130% of 46. Okay? So remember, is over of equals percent over 100. What goes in the is position? X. That's our part. They're asking us what part of the whole, and what's the whole? What do you think? 46. That's right, Lily, 46. Okay? Equals, and then Miss Hannah Beeman, were we given a percentage?
Yeah.
What were we given? 130 over 100. Okay. All right, here we go. Thank you very much. That's okay. That's all right. Okay, so the important part is we know how to set it up. Half the battle is setting it up. A lot of times we invert numbers accidentally. We put maybe an of number where the is number is and vice versa. Most of the time, most of my students don't miss the percent number. Most of them get that one. They invert the is and of number. So just want to make sure that we've got it where it's straightened out. Okay? So let me get Moss. How do we solve a proportion? All right, so let's cross multiply. X times 100.
100x.
All right, need a little bit of help. I need 130 times 46. 59, 5,980. And then, how do I solve this one-step equation? Divide by 100.
59.
And that's right. You can either divide those two numbers in your calculator, or if you just understand that dividing by 100 is the same thing as moving your decimal back 2 places, you could do it mentally. You could do it mentally. It's possible. Anytime you divide by a base of 10 or multiply by a base of 10, it's just all about moving the decimal, okay? All right, let me pause the video. I want you guys to work on the next one and see what you can. All right, we're back. We're ready. We have already worked out this problem on our papers. We're just going to verify the numbers here. So, Keenan, I want you to take the lead on this. How did you set it up? Correct? You got it. Great setup. Okay. Now, Catherine, how'd you solve it?
100x over 85 times 235, which is 19,975.
Okay, so when you multiply 235 times 85, you got how much? 19,975. Okay, kind of verification.
Yeah.
Okay, and then Chandler, how do you solve this from here? Divide each side by 100. You're exactly right. Remember, you can either divide these two numbers in your calculator or use your mental math and back your decimal up 2 places. Lyric, what'd you get?
Well, I think I got it wrong because I didn't get like the 19975.
Okay, and on your calculator, you multiply 235 times 85. And let's verify the number.
Yep, I got it wrong.
Okay. All right, take the 19,975 and divide it by 100 for me, and let's get that decimal.
Okay. 199.75.
You got it. Good job. 199.75. That's how much this month's heating bill is. Okay, that's how much it is. Last month was only $46. This month it's $199.75. So it really jumped up. Now, how did you know that, or last month's bill, I guess, was $85. Excuse me, I was looking at the wrong problem. So how did you know? Could you look at the percentage and tell just from the percentage that this was going to be much higher than the original number? How do you know? Yeah, the percent is well over 100. Okay? Anytime you go over 100%, you know it's going to exceed or be higher than the original number that was given, in this case 85. Okay? Good job. Good job. Let's look at example 3. Let's look at this one and see how we should set this one up. We got about 35% of an orchestra's musicians, or that counts out to be 30 members, are violin players. Find the total number of musicians in the orchestra. Now remember what I told you, when we do our proportion, is over of equals percent over 100. I told you that is your part and of is your whole, okay? Now, when I do problems like this, I usually look at what they're asking me first, because then I can kind of work backwards from there and figure out where the numbers go. Okay? So let's go to the word that tells us find. Find the total number of musicians in the orchestra. So what are we finding? Total number of musicians, okay, in the orchestra. So, is total number part or is it the whole? Which one is it? Can't be both.
Whole.
Okay. So some
Total
of you
number should be whole.
total number should be whole. Exactly. Will, you nailed it. Good job. Total number should be whole. Always. Now, look back at the rest of the problem. Did they give us the part earlier in the problem? What part did they give us? They gave us 30 because 30 represents what part of the orchestra? The violin players. An orchestra is not just violins. An orchestra is a myriad of instruments. And the violins are just part of that. So the problem gave us, this is part of the orchestra. Okay, like Will plays in the band, right? So Will is not the only member of the band. We don't only have piano players up playing in the band, right? Okay? It would be kind of weird. We want that diversification of sound. So does an orchestra. Okay? All right, so let's set this up. This time they gave us the part. They gave us the part. So where are we going to put that number?
Top.
It's going to be up top this time. 30 over. They're asking us to find total number, which Will just astutely said has to be the whole. So they're asking us to find it. We don't know it. What do we assign it? A variable of any kind. Now, do we have a percent?
Yes.
Yes, actually we do. 35%. So we're going to put percent over 100. Awesome. Very good. Okay. So again, cross multiply. Let me get Sydney Morris. Will you tell me what 30 times 100 is?
3,000.
3,000. And we're going to set that equal to the other diagonal, which is 35 times x. Okay? Now from here, how do we solve it? Sydney, go ahead and take the lead on that.
Okay, so we have 3,000 and 35x, and we're going to divide both sides by 35.
I like it. What'd you get when you did that?
So 35 divided by 35 cancels each other
Okay.
out.
Yeah?
So then 3,000 divided by 35 would be 85. I got a really long number here.
Are you done?
Yeah, 85.71428.
It ended up not being a whole number?
Right.
85.7. So we can't have 7/10 of an orchestra player. And it did, remember it said at the beginning about 35%? So about how many people are in this orchestra? Because we need to round it. Yeah, so we're going to say it's about 86.
The guy is missing the letter.
So, yeah, we're going to have to use our thinking caps just a little bit to make sense of the fact they did use the word about. So it wasn't a precise percentage, first of all, and then we're finding number of people in an orchestra, and I'm sorry, you just can't have 0.7 of a person. So it's not going to happen. He's either there or he's not. Okay, she's there or she is not. So we're going to go ahead and round that. We think there's about 86 people in this orchestra. 30 of them, the part, those are our violin players. The rest of them play other instruments. Okay, for a total of 86. All right, so now I'm going to stop it. I want you guys to go ahead and go on to this next one and set it up, see what you can do with it. Okay, Chase is going to help us on this setting up the bottom one. So how'd you set it up?
110 over x
110 over x
equals 40 over 100.
40 over 100, very good. So our scenarios, they're telling us about 40% of students in a school, and that's about 110 students, are in an after-school program. How many students are in the school? So they only gave us part of it. Not everyone is in that after-school program. Only part of the school goes to the after-school program, and part of the school does not. We want to know, out of the total number of students in the school, That's what we're looking for, is total number of students in the school, okay? And I like it when they write in there, find the total number, because the word total kind of jumps out at you and makes you think, that's got to be my whole, okay? I wish they'd had that here. It would make it a little bit easier on you, okay? So Chase, how'd you solve this?
I'm cross multiplying.
Okay.
10 times 100.
Okay.
11,000.
All right. 11,000 equals
40.
40x, and then what?
Divide.
Divided by 40, and what you got?
275.
Exactly 275? Okay, awesome. So that's how many kids are in the school, 275. So there's your whole amount. We know that part of them, 110 of them, go to the after-school program. Okay, so again, we're looking for part over whole. Part over whole. Okay, let's work to the next page. You guys did a most excellent job. And let's get to our last example in this particular section. And this time, can you tell from the numbers what's missing? Let me read it to you. The percent. 105 is what percent of 200? So the number that's missing, hopefully is clear in one of two ways. They're asking you what percent, so they're asking you what the percent is, so hopefully you're going, oh, I don't know the percent this time. You also don't see a number with a percent sign behind it, so you don't give them percent, okay? Now, remember what I told you when we set these up, your is word, if there's a number right in front of the is word, it can come after the is word. That's just one of those really unusual numbers that the number can come before it or after it, and you know that's got to be your is number, okay? Your of number, remember I told you it's very, very restrictive. It is, and can only come after the word of. That's your of number. The of number never comes before the word of, it only comes after, okay? So I just want to make sure I set the kind of those parameters for you. All right, Jaden, how'd you set this one up?
Wouldn't the percentage be X?
Yes.
And
So let's put that percentage right here, okay?
it would be is, and then is would be 200, and then O would be 105. Is it the other way around?
It should be, remember the of word, the number that comes right after the word of is your of number. And that goes on the bottom. So is over of, we want to put that 200 right down here. And then the is number, you have 105 is. That's your is number. So then that 105 can come right in front of the word is. All right, how do we solve a problem like this? How do we solve it? Lyric, what did you do?
You do 105 times.
What'd you get?
Was 0.06.
And what number is that?
10,500.
10,500 equals
52.
that would be 200x. Okay, so we're setting the diagonals equal to each other. Now, Lyric, how do you solve for x? Excellent. So we will divide each side by 200. And go ahead and do that in your calculator and see if you can figure out for me what that number should be. Sorry?
52.5.
52.5. Now, what kind of number did we just find?
A decimal, and it can't be this.
It is a decimal. It should be a decimal. But what were we trying to find?
The percent.
The percent. So should I have a symbol after this? Yes.
Just kidding.
When you're looking for percent, you need to put that percent symbol at the end. That's the percent we're looking for. So it's just a smidge over 50%, so 52.5%, really good, okay? Now I'm gonna pause our video for right now. Here we go. All right, Zach's gonna set this next problem up for us. 36 is what percent of 180? And Zach, go ahead.
I set it up like 36 versus 180
Yep,
equals X over 100.
great setup. How do you solve it from here?
180 X equals, and then 3,600.
Perfect. And then from here?
And then I divide 90 times that by 180.
That's wonderful.
And I've got 20.
You got it. That's exactly right. That's what number did you just find?
Percent.
So should we have a symbol behind our number?
Percent.
Yeah, we should have a percent symbol there. That's our missing percent that we were trying to find. Okay? All right, so let me stop the video. I'm going to just do a real quick exit.